Good afternoon, everyone. I deem it a great privilege to welcome and introduce our resource person, Dr. Surendra Kumar Dhaka, Professor, Department of Physics and Electronics, Rajdhani College, University of Delhi, for the technical session 2 on some intriguing features of air pollution and atmospheric dynamics in meteorological parameters. We welcome, sir. We have a wonderful person in our midst with a rich teaching and research experience of about 27 years. He is an active researcher who has completed 4 major projects on atmospheric science as principal investigator, which is funded by ISRO, Department of Space. He also set up a radio and atmospheric physics lab in Rajdhani College with the funding from ISRO. He has guided 10 PhD scholars who pursued research in the fields of radar remote sensing, satellite observations, thermal structure of atmosphere, climate system, convective system, and atmospheric waves. He maintains close relationships with the students and encourages them to pursue their career. Out of his 10 PhD students, 6 are now teaching as assistant professors in Delhi University colleges. He has also evaluated about 12 PhD theses from other universities, and he is a reviewer of more than 15 international journals. Dr. Surendra Kumar Dhaka fosters a good association with the international researchers in universities and institutes for over 2.5 decades and has served as a visiting professor in University of Tokyo, Japan, Yonsei University, Seoul, South Korea, followed by a role as a visiting scientist in Kyoto University, Japan, Nara Women University, Nagoya University, and as a visiting researcher in Osaka Electrocommunication University, Japan. He is also the co-convener in the international session with various professors from Japan, South Korea, and China of a special session of Middle Atmosphere Dynamics in Asia Oceanic Geoscience Society, Singapore, under Atmospheric Science section since 2006 every year. He has international collaboration with Nagoya University, Tsukuba, Japan, Kyoto, Japan, and national level collaborations with National Physics Laboratory, Delhi, Ares Nainital, NARL Tirupati, etc. He published more than 55 research articles in reputed journals and has attended more than 100 national and international conferences. He has also participated in many academic and research activities in Japan, South Korea, Australia, Sweden, Italy, Hong Kong, Taiwan, USA, Canada, France, and Germany. Sir, we are immensely pleased to have you here with us. Thank you for accepting our invitation. I hand over the session to you now.
Good afternoon to everyone. First, I'd like to thank to Professor Shamla. With her, I was interacting for last about 2 months, more than 2 months, and I'm really happy that I'm here in Lady Dock College. It's a wonderful time for me, and it's very encouraging here to be in the campus. I must appreciate. I think the initiative of your principal, Professor Kristana Singh, who is really, I think, the force behind you guys to organize all this. And I also thank to other professors of physics department and chemistry department, because it is a joint venture you are doing. And I could see some name, Dr. Elizabeth, Dr. S.K. Suja, of course, Professor Shamala sitting here, and many more young professors in the department. You are working together. It's really very great, and I must appreciate and congratulate to all of you. And of course, the most important is our lovely students sitting here. So thank you very much for inviting me here all the way from Delhi University. And I must share that one of your alumni, Dr. Jisha, she was a student here in this college, Department of Physics. And now she's a faculty member in my department, Rajdhani College and University of Delhi. So that's what, and at the same time, I think that let me recall that we had about 2 or 3 online conferences during COVID, and that made us really to think closer, and I'm quite hopeful that in future we can have some research work together with the department and research scholars. So, and I also thank Ms. Pooja. I think she's a radio astronomer. She's doing in the department. She's here. Yeah. So because she helped me yesterday, and then that's what means I came to know many things in Lady Dock College. So let me begin my talk. And as you know that honestly, Dr. Shamla was a bit hesitant whether the environmental things are basically getting fit in this conference. But you know, we are professors. We know how to get it fit. And that is what, because the people like in the morning, Professor Thomas and Professor Giri Babu, I think he left probably. And they were talking about materials and smart materials rather, making the best use of them, talking about nanotechnology. But you know what is happening in the atmosphere, because atmosphere is also one of your, environment is also one of your topic. And we must talk about environment when you do a lot of things, a lot of development, any kind of development, whether it is your buildings or it is your road construction or it is your industry. We all produce pollution, and this pollution of course is coming on the way, and you are very lucky because in Madurai I can breathe really easily. I can feel that difference. So once you are in Delhi, PM 2.5 is about like 250 microgram to maybe 400 microgram per meter cube, and which is very high. You feel suffocated. So there are a number of things which is coming as a kind of like gift of this development, whether you are going for the expansion of the city, making new buildings, using cement, using many other material, having a lot of cars, lot of like on the, you know, when the number of cars or number of vehicles are increasing in the city, this is really loading the environment and atmosphere, because there is a combustion of fuel, and at the same time they are running on the road, and you are having the fine dust particles. So these fine dust particles, they are basically going in the air, they are mixing in the air, and then ultimately your air quality drops. And this is what exactly we are studying for the last 5-6 years now, in collaboration with Japanese universities. And the most important point behind this study is like in the North India, including Delhi National Capital Region, and including the total Indo-Gangetic Plain, you are having, if you are having a satellite picture, you can see that the entire Gangetic Plain, starting from like Haridwar, then going down to like Meerut city, Kanpur, Lucknow, Banaras, is full of like brown clouds. And these brown clouds are basically the aerosols, tiny particles, they are hanging in the air. And but what are the sources for them? We need to understand from where they are coming. They are coming from like industry, they are coming from transport, they are coming from buildings, they are coming from many other, of course, long-term transport also there is. But why it is important to study? Because health is foremost for us. So therefore I'm just focusing now in this presentation to show you some basic idea that why the particulate matters, aerosols and tiny particles which can get mixed up in the air and ultimately they are going on your health. So therefore it is very, very important. So as I mentioned that we should talk about the air quality and health, and when there is a decrease in the air quality, because you know air quality index, so first thing which I did after coming here, I just checked the air quality of Madurai, perfect, green. So it is around like 70, 80, but you just amazing that if you are breathing in the air which has an air quality index like 400, 500, is suffocating. People are really getting asthmatic, and in the young children, when they go to school, and like in the morning you have to wear the mask, and not only this, there are a number of medical research articles now, and I know the IT Delhi and AIMS Medical Institute doctors, they are trying to formulate some kind of course who can really work together, who can think about from medical science point of view, also from physics and chemistry point of view. In the perfect way, like this Department of Chemistry and Physics joining hands together to carry out this, conducting this conference is really a matter of concern, because we are doing now interdisciplinary research, which is very important. Even I think National Education Policy 2020, they also gave a good emphasis on that we must target on the topics where the people can work together, from chemistry department, from physics department, from fluid dynamics, from biology. So there are topics which are unattended, but we can do them, and I think the justice can be done to those areas which are untouched until now. So I was talking about health. So you know there are studies, as I mentioned, and for the young children, the lungs size is reducing. Really is a matter of concern. Now their lung capacity is decreasing, and if you are having the toxic air, then definitely your outer part of your eye is coming in the contact of this toxic air, so you get irritation, and then you are having skin problem. So there are some skin cancers, they are also reported. And now if you just think about that, what kind of the particles we are inhaling, so there is a long range, and which I will show you that starting from PM10, PM2.5, and what is their meaning and how we can visualize those things, and ultimately where is the source. So somehow these smart materials, they are very important functional materials we need, which should not be the burden on our environment, and we should have a sustainable environment. That is the foremost basic idea behind this study. Like in the morning, Professor Thomas also talked about water, that he designed some beautiful nanoparticles, things from biomass. And Shruti was of course listening in the morning very carefully that time, because this is where many people can work together. And I was really happy that, because water is also another very challenging for all of us. Even in Madurai, because it's a beautiful city if you see from airport, but when we enter here inside, so there is a drain, and the drain has the same story like many other cities of India, because it is open, people are throwing plastic, they are throwing everything in the drain, and it is open. So you can understand that water cannot be used. But if we are having solid waste treatment plants, probably it has to pass through that, and then you can have whatever the water is going there, that can be reused for at least planting the trees, or maybe you can make, if you just go outside and you see Korea, Japan and all, even you can see the bottom of this drain, and you can see the fish. Usually what they do that, they allow all these small creatures to be there, and if they are surviving, it means the water can be utilized, and if not, it means something going wrong there. That is the basic idea about this. So I do not want to talk much about this water, soil and many other components. They are also part of our atmosphere, and environment, they are also contaminated. So whatever you are growing in the contaminated soil, probably we are getting bad fruits or vegetables, and finally we are consuming those toxic things. So we have to think a lot regarding on those lines. So let me show you some basic idea that what is particulate matter. You know, can you see this? I don't know whether you can see on the big screen here. This is a range of color, yellow color, PM10 is PM10 micron, and then we are having PM2.5. It means to PM2.5 micron diameter down to 0.1 ultrafine particles. And you know, these are very, very dangerous. The 1 micron is very dangerous if it goes inside the lungs. So probably there is a chance that it can get mixed up with the bloodstream. And during winter, because the PM2.5 concentration is very, very high, it goes up to like 400, 500, 600 on many days. And then once it is going inside your blood, so probably the brain strokes is also one of the component which is coming from here. And the number of patients are increasing during winter. They are having asthmatic problem. Even the young children, they can't breathe. And on average, probably we are losing 10 to 15 years our life, which is of course very good part of our life. So, and here on this side we can see these are the gaseous component which can basically convert. We hold these are the secondary component, and they are coming from like people also talk about ozone, surface ozone, which is also very dangerous for health. We are having sulfate ions, nitrate ions, they are also mixed up. And you know, there is a big variety, it's a long chain of these different varieties of the particles which basically a part of this air contamination. Here you can see that why particulate matter study or aerosols study is very important. You can see on the left side the ambient air pollution. These are the deaths in millions per year, and we are getting in India, I think they study about like 2 or 3 years ago, nearly 2 million people die every year, and this is one of the most like top 10 disease that which basically create a big pressure on our population. So if you are losing, not only you are losing this your life, but what exactly is happening about economy? Because the economy is about nearly, I read is nearly $40 billion we are losing because of this on health issues. And if people are dying, and we are having a burden on health system, and at the same time, I think it's nearly 1.5% of the GDP is wasted if you are not well. Number two, if you are exposed for about 5 to 10 years in this toxic air, probably there are many things inside, it is irreversible. So whatever the damage is done inside, then we cannot recover that. So that is another big problem. So therefore, studying the real-time observations of particulate matter in many big cities, especially where we are having the high risk of high polluted air, we must have that. And you can see on the right side that when you talk about the PM10, so mostly they are basically here, the coarse particles, they get stuck here, and you are having a difficulty in the breathing, you are having coughing, but most of them PM10, they are stopped here in the airways. But the fine particles, they go much deeper, as I mentioned, in the lungs, and then they become the part of the bloodstream, and then they cause a lot of damage. So these are the scenario why it is important to study our atmospheric system and the air quality index. Now, you know, the air contamination is consisting of the following part. We are having primary, secondary particulate matters, And from where they are coming from construction material we are using, cement industry, and many more. You are having paint industry, and all these aerosols, they go in the air during the construction time. You are having sand, and the sand fine particles, they also mix up. So whenever we are having a threat for, like we call graded response program in Delhi, so when the air quality index is going beyond like 400, so we stop many activities. No construction, no roadside any development, and even the diesel cars are stopped. And people, of course, it is they feel uncomfortable. They cannot use their car, and then only BS6 they are allowed. So at least for means in the last two months or 3 months, we had many problems. Like you have to stop many activities just to keep the people safe, whether they can breathe. But still, the condition is very, very bad. So here is, I think, on the left panel, you can see that these are sources which I already mentioned. You are having transport, you are having waste management, and waste management is also, I think, needs a lot of attention. In Delhi, we are having artificial like mountain, garbage mountain. So they are located in the north, west side, east side, and the height of those garbage mountains is beyond like prescribed limit, because very often there is a fire, and because of the methane emission, and methane emission is responsible for that. And once it is there, then definitely then you are injecting the emission of particulate matter, toxic elements is much more during this fire, and it happens many times, especially during summer when you are having high temperature. Then it is, I think, very often you can see. In the night, if you are coming from that side, you can see that everywhere it just like Deepak is growing everywhere. But this is a methane emission, which is making really a lot of problem. So maybe this is important for those who are doing this functional materials. So what is the composition of particulate matter? This is very challenging. It is mixed of many things. You have all elements, and since we are only taking observations of the particulate matter, we do not do the characterization, but National Physical Laboratory and many other, they do the composition analysis, and they found many times it changes with season. In winter, it is mostly from sulfate ions and nitrate ions, because mostly they are coming from the city, from transport. But during summer, because there is a long-term transport, we are getting sand and strong winds from the west side of Rajasthan. So we are having fine particles, and these fine particles, they are making a lot of contribution to our particulate matter. But during winter, it is just opposite. So sometimes the particle size is very circular, sometimes it's elliptical, and you are having layer-wise layer. So one layer is of carbon, another is by some any other element, and then we don't know really that when it goes inside, what are the impact. So each element may have a different impact on your health. So at least you can just have a look that the calcium, sodium, and the black one is coming from the coal burning. So you are having aluminium, selenium, cobalt, arsenic, and then you are having different sources. So, but at the same time, you just see that you are having all elements, and these elements, they are mixed up with moisture and with relative humidity if it is high. So then they get bigger and bigger size, and they are hanging in. We are getting fog, but eventually it becomes a smog, because during winter the temperature is low, you are having fog, and when it mixes up with the particulate matter, we call it as smog, and this is all black things, they are hanging in the air. The visibility is reduced, and of course air quality is reduced, so you have to survive in those very difficult conditions. Now at the same time, I would like to mention that it is not only primary particles, but they are secondary, and there have been some study, because after the emission of these gases from transport or from car or from buses, then there is a chemical reactions which are taking place, and it happens within a period of like 48 hours. So within that, then they are converted into another secondary substances, and which is much more harmful than the primary. So we are having a long-term observations, and we must do that in order to understand that whether over a period of like 1 decade, 10 years, whether something have changed or not. I'm going to show you that in the next view graph. So we studied in fact all about 35 stations in Delhi. So they are basically maintained by DPCC, Delhi Pollution Control Committee, and CPCB, Central Pollution Control Board, and we are having many individual observations by like IIT Delhi. Some smart sensors we are having. So these smart sensors are perfectly okay. You can carry with you, and in 24 hours we call this as your diary. Wherever you go, it can monitor and it can register, and you can upload this means in the night that okay, you went to restaurant and there was a smoke, and you are having PM 2.5 is like 700. Then on the road it may be like 300. So you can make a diary on your own, and then in the evening you can decide that you can escape those areas where you are having high exposure of emission. So this we can do, and we did in fact with our undergraduate students. So we combine the data from all these stations. They are having the longer data. So just have a look. This is your time here, starting from 2007 to 2021, and this is on the y-axis. You are having these are the microgram per meter cube values, and this shaded portion is basically representing 25 to 75%. But the most important point is this: that do you have the horizontal green line here? So this is basically the prescribed limit by World Health Organization, and you can see that always you are very high from that. And the another blue horizontal line, nearly 40, this is our national air quality index, and even we are not touching that, we are still above that national air quality index. So, but this is okay that you are having all the time nearly like 200, and Delhi government, central government is worried many times that what should be the steps I think should be taken by the government or by policymakers. So we can see from here that all the way you always touching like 200, 250, 300 microgram, but during winter, especially October, November, December, you see these are not wild points, they are real observation, and real observations is alarming. I mean, when the people come from outside, they are so really scared. Whether I remember a few years ago, the Australian cricket team, they declined to play in Delhi. They said no, we don't want because of this. So therefore, I repeat again, you are very lucky to be in Madurai in this area. It's really just wonderful. For me, it is just like Antarctica. I mean, I'm like, I can breathe this, I can feel that difference. So the next basic idea was to show you that from 2014 down, there is a decline, but decline is only like 3 or 4 microgram per meter cube per year. And it's only like over the last 10 years we could reduce maybe only 30 microgram, and where you are at 300, so it is only like 10%. So we have to do a lot. So therefore I asked question from Professor Thomas. We are having another big problem. During this winter we are having burning issues from Punjab. So rice residuals, because they are having farmers having a very small period. Within 2 weeks they have to clear their farmlands because they want to go for the next harvest. But the only thing is that they don't have any option until to burn everything in 10 days. This causes a lot of problem for Delhi NCR, and we are having, excuse me, yeah. So I was talking about that when there's a huge burning issue. So these issues are really creating a lot of problem for the people, and the contribution is nearly about like 30% we are adding during those 1 month, November. And if we have some kind of the technology to remove this garbage from the farmland, maybe farmers would be very happy. But the government is giving some subsidy about like maybe I heard 1,000 crore in terms of like instruments. They should buy new instruments, but it's not working at all. It's still, I think every year the number of counts using satellite data is nearly like 70,000 fire. It takes place in that particular area in those 1 or 2 months. During COVID time in 2020, we have seen that when everything was shut down, industry was shut down, and in Delhi we had a very natural environment. And people claim that they have seen from, I think they moved to the north, they could see the Himalaya from Punjab and the whole range. And this was a very natural cleaning of the atmosphere or environment. But we can't do that because then again we started with the same pace, and then things are almost we are at the same level. So in last year, the PM 2.5 level was same as in 2019. So except those periods, probably I think all big cities in India have experienced the reduction in the PM 2.5, and there were many news in the newspapers. I don't know whether those news really appear here in Madurai from north. Okay, so the next one is, just a moment. It got stuck, just a moment. Anyway, I think it got stuck, but I can speak because the basic idea to show this is that after 2014, yeah, is it okay? Because maybe it's Windows is not original, yeah, and it connects here. So my point was that the government should know if they implement something. I understand this is a stubble burning, and you can see the top panel from 2017 to 2021 and 22 is starting from here. These are the number of hotspots burning, and they are derived from the satellite. So satellite captured all these events, and then we try to correlate. So you can see the pollution was very high when you are having burning. So they are adding nearly from 30 to 40% of total pollution in Delhi and many other cities in the north. Just see the situation. This is November 21, and about a year ago, and these are the 35 or 37 stations, and you can see that each station is showing more than 200 micron. And I mentioned in the first view graph that what is the prescribed limit? It is only 25 and 40 by Government of India, National Air Quality Index. So at least 5 to 10 times toxic air we are breathing in that particular area. Okay, so these are the really scenario I just put in front of you, and we need to work on a smart material. It is important because both the things, it is highly interdisciplinary. We should know what is happening with the name of the development on our atmosphere, how our environment is basically going affected by all these construction, by transport, by number of cars increasing, number of buses increasing, and some burning issues, industry, cement industry, and we are having thermal plants about 15 in number in Delhi NCR, they are also contributing the coal unburnt carbon particles. So this is a kind of the gift from the development we are having. So we must go to the side of like smart material towards the solar side, so that we can really eliminate all these highly toxic elements from the air, and we can breathe. Nose should breathe like Madurai here. Thank you very much. Yeah, I think you can ask questions. Yeah. Maybe I request Dr. Shamla, if some student come forward to really work in these kind of
projects.
Project.
Yes.
So we can really help.
Yes, sir. I like to want to ask that question.
Yeah.
What type of projects you're carrying out
See,
here?
we can provide like data, and they should be smart in statistical tools, so that when they want to find out the correlation coefficient or something, they should know that it is like 95% significant, or at which level we are talking, and whether one parameter is basically influencing other parameters, but significantly.
Yeah.
So that you can really make a very strong line in your research papers that yes, you found this, and it is for like 100% correct.
What type of study they can do for exclusively for Madurai district?
I think they can, of course, it is very good, but at least they can use the whole year data of particulate matter and neighboring city like Chennai and Trivandrum, and they can compare with this, and the wind direction, whether they have similar situation like at Chennai, and temperature changes means for the next few years they can have a good prediction. So these kind of the which is of course involving atmospheric science, physics, chemistry. So all together we can see this.
Yes. Thank you, sir. Thank you.
Yeah. Any question from these young bright students? Okay, maybe you can write email to me. It's very easy. skdhaka@gmail.com. skdhaka, Dhaka, same Bangladesh capital, BHAKA. skdhaka@gmail.com. Thank you.
Now, I call upon Ms. M. Samira Farzana from 3rd BSc Physics to propose the vote of thanks. Good afternoon to all. It has been such an honor to be a part of this technical session. I extend my sincere gratitude to Professor Surendra Kumar Daha for demystifying us on the features of air pollution and atmospheric dynamics in meteorological parameters. Your approach on the importance of learning about atmospheric systems made us gain new insights, sir. Thank you so much. Thank you for the interesting and informative session, sir. As a token of our love and gratitude, please accept a small memento. Now I invite Dr. S. R.K. Shamla, Assistant Professor, Department of Physics, to present the memento to the resource person. I thank the organizing team and the technical team for the profound contribution in making this session a success. Lastly, I thank each and every one of you present here for your kind cooperation. Thank you. Innovation is not about ideas, it's about making things happen. With no further delay, let's start with the oral presentation. True guidance is like a small torch in dark forest. It does not show everything at once, but gives enough light for next steps to be safe. On behalf of Departments of Chemistry and Physics, Lady Rock College, I cordially invite Professor Dr. Surendra Kumar Taka, Rajdhani College, University of Delhi, to be the moderator of this oral presentation on energy storage devices. Please lead us through this session, sir. I now request Dr. S. Shamla Paniyarsi, Assistant Professor, Department of Physics, to present the memento to Professor Surendra Kumar Taka as a token of respect and gratitude. These are the instructions to the oral presenters. The time allotted for each presentation is 5 minutes and 2 minutes is for discussion. The presentation should have a maximum of 7 slides only. The presenters are requested to adhere strictly to the time given and the number of slides. I repeat, the time allotted for each presentation is 5 minutes and 2 minutes is for discussion. Presentation should have a maximum of 7 slides only. The presenters are requested to adhere strictly to the time given and the number of slides. Oral presenters can be ready with their presentations. Oral presentation 6, please get ready.
Dear participants, kindly note the venue for oral presentations on the theme Multifunctional Nanomaterials. Oral presentations OP1 to OP5, OP9 to OP14, venue AV Room 2. I repeat again, oral presentations OP1 to OP5, OP9 to OP14, venue AV Room 2. Thank you.
Good evening everyone present here. I am R. Bhuvaneshwari, doing PhD under the guidance of Dr. S. Shamla, Associate Professor and Head, School of Physics, Madurai Kamaraj University, Madurai. Here I am going to present a part of my research work entitled Synthesis and Characterization of GO as Cathode Material for Supercapacitor Applications. Energy prices and global warming are the prevalent challenges in the 21st century. Increase in energy demand and deficiency of non-renewable fuel sources directs the researchers to investigate towards the alternative sources of energy. To overcome these issues, electrochemical energy storage devices are used as a solution of it. Among electrochemical energy storage devices, supercapacitor and battery getting more attention. We can compare supercapacitor with a glass of water, where we can store a less number of water, but whenever we need water, we can easily get out of it. Like that, supercapacitor, we can store a minimum amount of ions, but whenever we need the ions, it can easily deliver. That's why we call supercapacitor has high power density, that is fast discharging but low energy density. We can compare battery with a container, where we can store more water, but whenever we need water, it is some difficult to get out of it. Like that, battery can store more ions, but it suffers from delivering the storing energy. That's why we call battery has high energy density but low power density. So that we are going to combine these two systems in a single hybrid system called supercapacitor, where supercap comes from supercapacitor and earthly comes from battery. So that the mixed hybrid system, supercapacitor can deliver high energy density and high power density, like we can store a water in a large jar. So, in a material basis, supercapacitor possesses two types of mechanism. One material should possess the capacitive charge storage mechanism, and another one should possess the Faraday charge storage mechanism. Here I am going to present a material which is used as a power source in a supercapacitor medium. We choose graphene oxide due to its large surface area, high porosity and good electrical stability. Due to its 2D nano sheets, it possesses highly conducting network. It helps to fast ion transport throughout the material. So, modified Hummer's method was adapted to synthesize the graphene oxide. We are going to the characterization part. The prominent peak of graphene oxide is 001 and 002 and 100 plane confirms the phase formation of graphene oxide. Absence of other peaks confirms the successful preparation of G1 nanomaterial. G1 is a highly hydrophilic material. So, from ATR analysis, the presence of very broad peak at 3404 cm inverse, which is corresponds to the OH of H2 molecules, confirms we prepared the graphene oxide, which is highly hydrophilic material. The other peaks confirms the carboxylic groups, which is present at the edges of graphene oxide nanosheet. The other peaks, which is corresponds to the carbonyl and hydroxyl group, which is present at the surface of graphene oxide nanosheet. The nanosheet was confirmed from scanning electron microscope. We can see in some image it is a wrinkled sheet-like morphology where it possesses fast transfer of electrolyte ions, which in turn increase the power density. So that we call graphene oxide is a power source in supercapacitor applications. The electrochemical performance study of analyzed via cyclic voltammetry and galvanic charge discharge analysis. The capacitive charge storage mechanism of graphene oxide was confirmed from leaf-like structure from cyclic voltammetry and triangular shape charge discharge analysis from GCD analysis. The specific capacitance of this graphene oxide was found from the GCD analysis. Finally, we conclude that graphene oxide was successfully synthesized via modified Hummer's method. The structural characterization of this graphene oxide was analyzed via XRD and SEM analysis. The sheet-like morphology of graphene oxide, which increases the fast ion transfers throughout the material. The electrochemical performance confirms the graphene oxide we prepared should act as a power source, which obeys the capacitive charge storage mechanism, and the maximum specific capacitance of graphene oxide was attained 116.96 farad per gram at a 1 ampere per gram current density. Hence, these excellent properties suggest that the prepared graphene oxide may act as a better cathode medium for a supercapacitor applications. These are my references. We thank RUSA for providing the financial support to carry out the research. Thank you, everyone.
Bhuvneshwari is really good and it's a good presentation. I have one quick question. That what exactly you mean by supercapacitor? What do you mean by it? How much should be the capacity? Supercapacitor. So how do you define this? What should be the capacity? I mean, in terms of super and normal.
In supercapacitor, we use as a specific capacitance, where it should be in a farad per gram, not in microfarad or nanofarad. It should be in a farad per gram.
Okay.
When we attain the specific capacitance in terms of farad per gram, then we possess that material support supercapacitor applications.
Okay. So in your proposed study, do you think that how much you have achieved?
116 points.
Okay. Okay. And my last quick question is this: do you understand the meaning of SEM? SEM, SEM?
It's a scanning electron.
What is it?
It confirms the morphology of the prepared material.
And what is the resolution?
It's a micrometer range we chosen here.
Okay. Yeah. Thank you.
Thank you.
Like what was the difficulty you faced when during the characterization of your cathode material?
Yes.
The preparation. Yeah.
Preparation, we have to oxidize all the graphite. We have chosen as a precursor in it, ma'am. So graphene oxide, it should be the carboxylic group should be present at the edges of, ma'am, not inside the medium. So if we prepare the graphene oxide, it should be in a hydrophilic material, ma'am. If it dispersing is happen inside the water, means that we do not prepare the graphene oxide, ma'am. So it should be highly soluble in water.
Normally it's a very difficult process.
Yes, ma'am. Yes.
How many trials you took to have
We
it?
have synthesized this material for 6 months. First of all, we get a small yield, ma'am, so it is not sufficient to undergo all the characterization, ma'am. After that, we have to increase the precursor. So for that, we have to optimize all the weight percentage of the water and other things.
Okay, right. Good work. Okay.
Thank you. Thank you. Thank you, sir.
Time up. Just see the time.
Oral presenters 16 and 17 are yet to submit your presentation. Please send it to FMSE mail. Next, I call upon oral presentation number 7 to present.
Yeah, please see to your time also.
Good evening, everyone. I am Kavya. I am doing my PhD under the guidance of Dr. Mr. Ali Shabla. I am here to present a part of my research work entitled Improved Electrochemical Hydrogen Storage Performance of Biomass-Derived Activated Carbon from Jackfruit Seed for Fuel Cell Applications.
Full screen. Make it a full screen.
These are the outline of my presentation. The general motivation of my work is because of the rapid development of global warming, that's increasing the usage of fossil fuel. These fossil fuel increasing the climate changes and creating lots of greenhouse gases that eventually end up with global warming. From the global warming, we are facing a lots of energy crisis and energy demand. So we need to find some alternative energy storage devices that should overcome these issues. And these are some newspaper articles revealing that the usage of fossil fuels in past 2 years, and they are revealing the death rate of in 2022 over 330,000 people died because of the particulate released from fossil fuels. And the third article, we frequently hear that the burning of e-vehicles, oil charging. So what we need to do to overcome these issues is a main question mark yet. And the government of India, Lok Sabha, passes a bill to use the non-fossil fuel electric vehicles. So in order to overcome these issues for present and future, we need to find energy storage devices that should overcome the issues and that should be cost effective and reliable. So in that way, many countries are stepping into the usage of hydrogen based energy storage devices. In that way, the first 3 places are China, Japan and South Korea, having a more number of fueling stations for onboard vehicles as per 2022 statistics. But our India has only 3 fueling stations. So our ultimate aim is to increasing the usage of hydrogen storage and hydrogen based vehicles. So in that way, I am choosing hydrogen. Why hydrogen is important compared to all other energy storage devices? So hydrogen is abundant in everywhere. It has only byproducts when we use its water and heat, and we can easily generate it from photochemical reactions and water splitting and many more. So the main issue is storage of hydrogen. How we store hydrogen? It is still a chaotic task. So I am adapting in this work is fully based on hydrogen storage. There is a classification of hydrogen. There is 3 types. One is compressed hydrogen, liquefied hydrogen and solid state hydrogen. Compressed is hydrogen stored in a gas form in 300 to 750 bar. So it is tedious to transport from one place to another place. It has a safety issues. Then we move on to liquid storage. In liquid, we need to store hydrogen below the cryogenic temperature, that is minus 253 degrees Celsius. So that's we need to mount high insulation. We need to mount. So that is cost high cost. So we move to solid state hydrogen storage. That is two types. One is thermal hydrogen storage and another electrochemical hydrogen storage. Thermal hydrogen storage is usually hydrogen gas is purged to the host material under a particular temperature and pressure. In electrochemical hydrogen is fully based on electrolysis, where we get hydrogen ions from electrolytes. And United States of Department Energy has fixed some targets for host materials that should be gravimetric density 5.58% and for volumetric density 40 gram per liter. So based on this, I have adapted jackfruit seed is my host material. Why I am adapted is in southwest of Tamil Nadu, it's called palapalam, because people demanding of the fruit, it was harvested prematurely and dumped into the landfill. It gets wasted, and the edible part of the fruit is only 25 to 35%, remaining all waste contents. In that aspect, I have adapted this as one of my material. And also seed has naturally water absorbent property. In that aspect, it might be act as a good absorb material. And this is the synthesis part of my material. It's direct one-step chemical activation method. As usual, the seed is collected, washed several times, watered under the direct sunlight, then it was finely chopped and it's powdered. Once gets it grounded, the same image was taken. There is no host were noted. It's like a dry sand. After activation with KOH and high temperature pyrolysis, we can see the hierarchical dense pores. So activation and pyrolysis plays a major role in creation of pore formation. And result and discussion, these XRD and Raman confirming the formation of amorphous carbon, and these speaks confirming the amorphous nature of prepared material, and ID-Ig ratio of the prepared sample is 0.85, so it is having the defective sites in the surface. And the same image is confirming the formation of pores in the surface. These pores will help to ion transportation during electrochemical interaction, and it is also confirming the presence of only carbon and oxygen. There is no other elements traces is noted, so it is confirming that purely activated carbon. And final application part, CV confirming the leaf-like structure. This exhibits the EDLC behavior of the sample, and there is no oxidation reduction hump is noted. From that we can confirming that the charged ions are stored at the surface of the electrode, not the interstitial sites of the electrode. And the discharge capacity confirming 1860 at 30-second cycle. After 33rd cycle, it's decreased to 1500, then it retains its same discharge capacity. So this capacity is rely only on morphology and voids. As these are some previously compared results with other activated carbon material. Compared to all other, our pristine jackfruit itself has a maximum number of discharge capacity and cycle number compared to all other. So it is the best active material for fuel cell applications in the near future. And conclusions, the chemical activation method is adapted and electrochemical performance is adapted and hydrogen storage capacity is tested. So it must be a best electrochemical electrode for fuel cell applications. In future perspective, the first three are fluctuating renewable energies. From that we can get the electricity, and by that we can generating the hydrogen, and we can generate a hydrogen should stored in a medium. That medium should be act as our prepared material. From that we can give a source to any fuel cell or any charging station. This is our future perspective. I thank my funding agency for providing a financial support, DST cell, and I thank my university. Thank you.
Kavya, I think it's a really wonderful presentation, and you are looking forward some alternative sources, which is very much required. I have a question, like what should be the pressure for the compressed or liquefied hydrogen?
So it's 350 to 700 bar.
Okay. And at the last, I would like to know that, because you mentioned that you feel it is a like 4% capacity?
4.2 weight percentage.
Okay. So do you have any idea any other material like used or?
Yes, sir. I am planning to dope with some other metal oxides and polymers to enhance the discharge capacity of the individual carbon material.
You are a master student there or doctor?
No, sir. I am PhD student.
Okay, oh, thank you very much.
Thank you, sir.
Yeah, very good work. I have one question.
Yes, ma'am.
What about the stability of your material?
Yes, ma'am. As of now, it's run for 20,000 cycles, ma'am. We are planning to enhance the cycles by doping it with some other material.
Okay, good.
Thank you.
Nextly, I call upon oral presentation number 8 to start with the presentation.
Good afternoon, everyone. So I'm here to present a part of my master's thesis where we explore the different applications of activated carbon nanoparticles. So one of those applications is for solar cells, and that's what we've put a paper on right now. Okay, so without further ado, I'd just like to start by saying that we all know that the demand for alternative energy resources has been increased manifold in the past decades. So in order to meet these demands, it is very important that we have some greener and cleaner technology that can replace the existing fossil fuel based technologies. And one such material is carbon. Carbonaceous materials and carbon-based materials are very important in serving the society because it can be used for a multiple amount of purposes, such as in the food industry, pharmaceuticals, energy storage, etc. And also producing this activated carbon from a bioresource means that we are not even involving any chemicals in the activation process. So it is much cleaner and much greener. And our bioresource that we took is the Mimosa pudica plant. Mimosa pudica, also known as the touch me not plant, as you all know, responds to touch and any other kind of sensor reception. So why do we use Mimosa pudica amongst the variety of plants that are present? Even the previous presentation talked about jackfruit seeds, right? So why do we opt for this particular plant? First thing is the plant is abundantly available in our area. It can be found anywhere, and it is a bush. So a lot of leaves can be taken from a single plant itself. And it also, studies have also shown that Mimosa pudica, when it's growing on the soil, it extracts the copper, lead, tin and zinc from the polluted soils. So if it already has such great properties, we thought why not tap into its untapped potential and harness what it has to offer. And it is also important to note that the plant is non-edible and it cannot even be used as fodder for cattle because it has thorns in it. So it is ultimately going to go as a waste, so why not use it for such a great purpose? And I'd like to say that there was not a lot of existing research regarding this plant in this particular field of electrochemical performance. So we were struggling to find references even to begin this project. Okay, so the methodology. The method is very simple. It is a one-step thermal activation. We are not using any activating agent in the process. The leaves are dried in shade. They are picked up, washed and dried in shade. They are not to be placed in sunlight because we do not know about the exact photo processes. So yeah, this was my introduction slide. Okay. So it responds to all kinds of stimulus, and it has seismostatic movement. And because of that, we have to be careful where we are drying this. We cannot dry it in the sunlight because it will shrink and all that. So we dry it in the shade and we grind it into a fine powder and sieve it multiple times to get fine structures. After that, we also made 2 other samples where we dope it with cobalt chloride and copper acetate separately. And then we place it in a muffle furnace for about 4 hours from 400 to 500 degrees Celsius. That was the optimum temperature that we used. So this is a one-step process and it does not require any kind of chemical activating agent. After we characterized these samples, the 3 samples that we had, from the FTIR studies we found that there was a strong carboxylic and hydroxyl groups present which paves way for the pseudocapacitive behavior of the samples. And there's also a nitrile group present which indicates good conduction behavior, and when compared to the plain activated carbon, the doped carbon had some gradual differences indicating the interaction of the metals with the carbon. So the UV spectrum analysis was our next step because we wanted to know what was the conducting range of our sample, and when we did the torque plot and obtained the band gap, we found that the band gap was very low and it was in the semiconducting region. It was between 2.35 and 2.75 electron volt, whilst plain carbon is an insulating material, as we know. It has a band gap about 5.4 electron volts. So this reduction in the band gap was also observed when we added the dopants. So the undoped plain activated carbon was around 2.75, and because of the doping it reduced to 2.35 and 4.5, and the doping with cobalt chloride yielded the least band gap. Then we did our XRD analysis, and there's 2 peaks, one at 002 and 001 graphitic planes, and it showed, from this we can see that it shows a hexagonal graphitic stacked structure, which also again contributes to the conductivity and pseudocapacitive and supercapacitive behavior of the samples. In order to study more about the capacitive behavior and charge retention, we did electrochemical studies such as cyclic voltammetry, which was done in a 3-electrode system. And from the calculations, we revealed that the specific capacitance was very high and it was very stable. Electrochemical impedance was also done, and the resistance was found to be very low. So the applications is solar cells. We can use it as a counter electrode material for solar cells. The plain carbon is often used, but this activated carbon proved to show a much better result. FTO conducting glass was used as a substrate, and the TiO2 layer was added. The sheet resistance found using 4-probe method was very low compared to plain carbon. Other applications such as supercapacitors, dye degradation and heavy metal removal can also be done. In this we have X-node supercapacitors and dye degradation in detail in other papers that we have published. And supercapacitive behavior is very great because of the high specific capacitance, as I mentioned, and it is also seen to degrade dyes such as methylene blue, etc. Via the several UV studies that we conducted. So I'd like to conclude by saying that biomass precursors are today's rage because they give a very porous structure that can be made, that can be improved by a pyrolysis process. And this being a one-step thermal activation process without any interference of chemicals, we can confidently say that it is a green and sustainable technology for electrochemical studies. We are also planning to do the same in the future using sunflower stalks because they also have photosensitive behavior that we want to explore in detail in the future. These are my references. Thank you.
Jasmina, I think it's really good. You are finding something new.
Yes.
So I just want to know that do you have this facility of increasing the temperature up to like 400 degrees centigrade?
Yes, but we did try it because we did a lot of trials and errors for obtaining this optimum temperature. And what happened was that when we increased the temperature to say 600, it became ash. The carbon oxidized and it became ash, so we could not use that material at all. Just if we open it itself, it will fly away. That was the situation of the thing. So we thought we can reduce the number of hours and increase the temperature, because now we are doing it at 4 hours and 400 degrees. So we thought we could reduce it to 2 hours and try it at 600 degrees, but the result was not as satisfactory as this optimum temperature.
Thank you.
Yeah, really a good work. You said you did for the first time.
Yes, ma'am.
How did you frame your experimental part like? On what basis?
So we saw a lot of references while doing this, and all of them used chemical activation, KOH activation, physical activation methods. So we thought it's just carbon, right? So if we burn, we might definitely get carbon. And we thought, why not just try that instead of moving to the expensive alternatives of buying chemicals and stuff? Because as you know, we are just master students, so we do not get any funding and stuff. So we thought of trying a cost-effective and cheaper alternative. And even that itself gave us a lot of good results. So we thought, if maybe we are doing this in our PhD, we'll expand it to other methods also and compare and see what the results might be.
Can you define what's the fill factor?
So fill factor is when we're talking about solar cells, we'll talk about fill factor. It is basically the one to show the efficiency of how the solar cell is operating and how much it can hold, how much charge it can hold. And so.
Okay. Thank you. Good
Thank
work.
you.
All the best.
Thank you.
Participants are asked to stick to the time. Now let's start with oral presentation number 15.
Good evening, sir. Good evening, ma'am. My topic is synthesis of vanadium trioxide by precipitation method for application of supercapacitor. So my outline and my introduction. So energy storage is nothing but energy produced at one time for use at later time in capture of energy. Means the devices are called as accumulator. Energy comes in multiple forms including radiation, chemical, gravitational potential, electrical potential, electricity, elevator temperature, latent heat and kinetic energies. Next, types of energy storage. There is chemical, electrochemical, electrical, thermal, mechanical energy storage. These are types of energy storage, ma'am. Next, specialties. So the supercapacitor is compared to battery, it's very low energy density and very high self-discharge. Next, this is my technique for sample 1 and sample 2. Sample 1 is with the surfactant. Surfactant is cetyl trimethyl ammonium bromide and without surfactant is this one, ma'am. My sample 1 is first ammonium metavanadate, adding some distilled water, the continuous shrinking and nitric oxide some added. Next my surfactant is added, the NaOH solution added continuous shrinking. The NaOH solution is maintain my pH level and I get some yellow precipitation. The yellow precipitation in 80 degrees Celsius dried powder, ma'am. This is my XRD pattern and I get some rhombohedral structure. The red color ranges my with surfactant and black color is without surfactant. And this is my FTIR. FTIR I get some hydro-oxygen and carbon dioxide. And my conclusion. The vanadium trioxide particles with and without surfactant prepared from yellow precipitation and XRD and FTIR solutions are added.
Thank you, Satya. It's really good. You came all along from Pioneer.
Yes, sir.
Yeah. So have you tried for any other samples? Why only V2O3? Do you have any idea why you have selected this? Why not others?
So this is some slow poison level chemical, sir. So I tried to use this.
Okay.
Right. Good work. You have started well. Any other characterization techniques you will be studying for your further investigations, or you are going to stop with this XRD and FTIR?
This only, ma'am.
Because these are very preliminary studies. Like you need to concentrate on your main property study, yeah? So you can even go for it. Okay, you will get wonderful results. Good, very good.
I request oral presentation number 18 to start with the presentation.
Good afternoon, sir. Good afternoon, ma'am. And preparation and characteristic of PDA-based dye-synthesized solar cell is my topic. And I B. Aisha Lakshmi from Nada Sasai College of Arts and Science under the guidance of Mrs. Ishwari, MSc, PhD, and this is my outline. And introduction says that solar energy is readily available source of energy, increasing and gradual depletion of fossil fuels. I have used greener methods in mechanics of solar energy, solar to thermal, voltaic, chemical energy for various applications. Nanoporous and dye-synthesized solar cells are promisingly used for solar cell to convert electrical energy due to low fabrication cost, environmentally friendly, and operation and relatively high efficiently. And preparation of my polyvinyl alcohol. Taking PVA plus distilled water. For continuously stirring, I have obtained PVA gel and organic dye preparation. I have extracted Bacilla alba plant and extracted the organic dye and added some ethanol. Continuously stirring up to 400 room temperature at 50 degrees Celsius. Dip coating process of mine. The glass plate is taken and one side is taped completely and another side is fully cleaned with acetone. 30 ml of PVA gel is taken and one side non-taped glass is to be dipped up to 3 continuous steps, and first and after 15 minutes the second layer of organic dye, and finally these 2 layers of polymers and organic dye were dried, and then the tape was removed from the second side. And my spectroscopic studies in 50 degrees Celsius, wavelength B 537 nanometer, and my band gap result B 3 electron volt. In 60 degrees Celsius temperature, my wavelength B 342 nanometer and band gap B 2.6 electron volt. In 70 degrees Celsius, wavelength B 298 nanometer and band gap B 2 electron volt. In 80 degrees Celsius, lambda B 343 nanometer and band gap B 1.7 electron volt. Here we can see that by increasing temperatures, wavelength decreases and also band gap also decreases. In XRB studies, particle size differentiation has occurred. In increasing temperature, I have resulted increase in particle size. Conclusion: polymer-based solar cell were prepared by Bacilla alba dye and polyvinyl alcohol. The absorption wavelength B 50 degrees Celsius to 80 degrees Celsius between 250 nanometer and 600 nanometer. Band gap B 3 electron volt, 2 electron volt and 2 electron volt, 1.7 electron volt. The particle size varies by XRD by D by Schroeder's formula. Thank you, sir.
Ishwari. Yeah, thank you. So can you explain that why when you are increasing the temperature, why it is shifting towards the lower wavelength?
In a normal room temperature, I can't get correct band gap and wavelength, sir. So I have moved to another temperatures like 50, 60 and
So are you satisfied with the band gap now you already obtained?
Yes, sir.
Are you satisfied?
Yes, sir.
Because it is like the last one is 1.7 electron volt. How much it was the last at 80 degree?
1.7 electron volts.
So are you happy with this?
No, sir.
No?
Because some slight difference has happened, I think so.
Okay, thank you.
Thank you, sir.
Yeah, one last question. As you anneal, the grain size increases.
Ma'am?
The crystalline size increases as you increase the temperature.
Yes, ma'am.
Is it good or bad?
Good.
What do you expect?
It's good one.
Why it is good?
Because it's low fabricated and eco-friendly.
Okay, right. Okay, good.
Thank you.
Thank you.
I call oral presentation number 17 to start the presentation now.
Good evening to one and all present here. Myself, P. Sanchita Banu. I am doing PhD under the guidance of Dr. K. Mohan Raj in MS University. My topic is a non-toxic and low-cost hydrothermal route cause synthesis of wide bandgap trigonal Fe-doped copper barium tin oxide, copper barium tin sulfide nanoparticles for multi-junction solar cell applications. Here, the preparation of copper barium tin sulfide nanoparticles was done by hydrothermal method. Initially, the copper, barium and tin or chloride precursors has been taken in the ratio of 2:1:1 and 4 mole of sodium sulfide precursor was taken and it is mixed well in 40 ml solution and kept for 230 degrees Celsius 24 hours in a Teflon line autoclave, and the obtained precipitate was subjected to characterization. Here in the XRD result, the prominent peak I have observed at 110 plane. Here on doping Fe, the peak shifted to higher angle, the crystalline size decreased and the microstrain level increased and the dislocation density also increased. In the Raman analysis, a prominent peak observed in 351 cm inverse. It belongs to trigonal copper barium tin sulfate phase, and all the other peaks are binary secondary phases. The peak at 200 cm inverse belongs to barium sulfate, 142 cm inverse belongs to tin sulfate binary phase, and 473 cm inverse belong to copper sulfate binary phase. In both copper barium tin sulfate and Fe-doped copper barium tin sulfate. In UV analysis, I observed the band gap has been shifted from 2.14 to 2.9 electron volt, which is known as the bursting Moss effect. On doping, the conduction band with electrons, making the CBTA system undergo degeneracy, which shifts the Fermi level to higher energy level, increasing the band gap. Here, the copper barium tin sulfate is a cursate-based solar cell material. The prominent cursate-based solar cell material is copper zinc tin sulfate. Because of the anti-side defect and binary phase formation, the efficiency is not much good in CEZTS. CBTS is a good alternative for that material, yet it suffers from a bottleneck which is called as band gap tailing. This Arbeck energy calculation, that means this Arbeck energy is a proxy for finding the band tails present in the copper barium tin sulfate material. Using this formula, I have calculated the Arbeck energy, which is found to increase while the concentration of the dopant Fe increases. From FMSEE analysis, I found that the mean particle size of the copper barium tin sulfate is higher than the Fe doped copper barium tin sulfate. The dopant Fe reduced the mean particle size, preventing the surface recombination, thereby increasing the photoconversion efficiency of the material. In XPS analysis, I have observed that the oxidation state of all the elements present in the sample, copper belongs to copper plus, and the oxidation state of barium is found to be barium 2 plus, and tin is found to be tin 4 plus, and sulfur is found to be S4 minus, which contributed well with the stoichiometrical molecular formula of the material CBTS. In Fe doped CBTS, the oxidation state of Fe is found to be plus 2, and moreover, the dopant Fe increased the oxygen vacancy. From figure 7E, we can see that the dopant Fe increased the oxygen vacancy in the Fe doped copper barium tin sulfate sample. Electrical studies were done by 3 electrode systems. The working electrode is the material, and the counter electrode is the platinum, and the reference electrode is AgCl. Here I have observed a significant change while doping the copper barium tin sulfate with Fe, which shifts the Fermi energy level, thereby making the p-type conducting nature of the copper barium tin sulfate to n-type conductivity by increasing the number of the carrier concentration, that is the electron carriers. At high concentration Fe dopant, the conductivity has been changed. It is observed by Morshatsky plot. From JV plot, it is seen that the efficiency has been increased on increasing the concentration of dopant Fe, which means the dopant Fe could help. From Motley's plot, it is observed that the carrier recombination is delayed by Fe dopant, and from Tafel plot, it is seen that the electrochemical reactions is better for Fe doped, and the limiting current density also decreased for Fe doped copper barium tin sulfate. Thank you.
Very good work and a detailed work. So, can you come to a conclusion based on any on your properties of your study?
Actually,
because you have done a very good job. Okay, you have studied a lot. And what is come to any one point of conclusion about your?
Yes. Mostly for cursate-based solar cell, CEZTS were widely used, which the efficiency of CEZTS is 12%. But even though the decades of research were going in CEZTS, but the major 3 problems they could not. They could not rectify it, that is the binary phase defect and the anti-side defect and the band tailing. Here, the anti-side defect could be reduced by copper barium tin sulfate. Here, zinc is replaced by barium, which has a different ionic radius. Hence, there is not possible for this anti-side defect. And the binary phase formation, barium sulfate is a very less stable in compared to zinc sulfate. Hence, the secondary phase defect also reduced. Here, I have my sample. I found secondary phases have been formed, but these secondary phases increased my band gap. Because of the increase in band gap, my aim is to prepare a multi-junction solar cell in which the copper variant tin sulfide is a top cell. In top cell, the band gap should be more than 2.4 in order to absorb the blue light. In order to precisely absorb the blue and indigo light, I have tuned this band gap to I have tuned the material to get high band gap.
Okay, so you are going to work for increasing your band gap. Okay, good.
Presentation number 20 can come here to present. Oral presentation number 20 can come and present.
வாங்க அங்க போயிட்டீங்களா? ஓகே, சீக்கிரம். ஓ, எக்ஸல் வரீங்கம்மா? இந்த ஊர்ல the band is tomorrow fast. The 3 white and you all need to listen here.
Good evening to one and all. Power generation using agriculture waste of groundnut peel as biochar in soil microbial fuel cell. In my topic, I am Dinesh Krishi, Research Supervisor, Dr. A. N. Sindhil Kumar, Alapa Government Arts College, Karaikudi. Introduction: chromium toxicity. Most of the environment chromium toxicity in the soil and environment. So industrial mining and anthropogenic activities are major sources of the widespread of chromium 6 in water and soil. Chromium 6 is stable oxidation state of chromium causing mutagenic and carcinogenic causes. So preserving ecosystem. So physico-chemical approach and a biological approach. Bioremediation technique for this biochar based of the material of groundnut peel. So bacteria and fungi are the organism produced at the soil microbial fuel cell. The power of generation of single chamber of soil microbial fuel cell using soil organic matter as a fuel source. So generating power, microorganism sources catalyzed, soil carbohydrates are utilized as a fuel, device for converting waste to health. So presenting work, chromium 6 in soil microbial fuel cell using soil bacteria and fungi. So reduce behavior of explicit potential in the constructed cell. So we examined the effect of soil with biochar and different concentration of chromium solution, depth, the room temperature of the atmosphere. So SMFC is anode and the cathode of SS plate, stainless steel plate. So in the overlaying of chromium solution, thickness of 0.5 mm. So not carved of the stainless steel. This setup. So 3 cm deep in soil anode and exhibit the highest open circuit voltage 783 millivolt, but 0.2 normality of the chromium 6 concentration. So chromium 0.2 normality of chromium solution is long days working in the setup. High electricity produced 783. So the 30 days after biofilm is formed. So the biofilm is collected in the SEM and XRD is measurement. So methodology. So experimental soil plus biochar gives fuel. So load of chromium 6 concentration and reacted chromium 6 concentrated 0.1 so normality. So 0.0978. So potential measured on various days. 96 days continuously working in this setup. 0.2 normality of chromium 6. So binding energy of binding material of biochar plus soil gives converted into power generation. So the long term is working in the 0.2 normality of chromium solution. So XRD spectrum of Arachis hypogea, groundnut peel. Next FTR spectrum of Arachis hypogea, chromium solution, different concentration. So different concentration of the functional groups. Same image of the EDAX image, biochar and biofilm. So Nyquist plot impedance of the real image and imaginary part. So highly participle in the impedance resistance of the image. 0.2 normality of chromium 6 solution of the setup. So impedance, circuit and resistance. Cyclic voltammetry for biofilm in different concentration. Before and after. Before means biochar plus oil plus setup. After means after CB setup was collected in the chromium solution and biofilm. The setup is connected to the cyclic voltammetry. So conclusion. The study that concluded that biodegradation of chromium is possible in FMSEs within the limits of 0.1 normality to 0.2 normality. My best work is 0.2 normality chromium 6 loaded. FMSE clearly revealed the chromium toxicity.
Yeah, thank you, Dinesh. I have only one quick question because in the graph which you have shown, so corresponding to about like 20 days or how many days that you got the peak?
Yes.
That was the, nearly 20 days. Okay. So why it is happening at this gap?
Biofilm is formed these days.
Okay.
So soil, agricultural fields soil plus biochar. So binding of the this structure. So high peak and biofilm is overall formed this.
So how do you really control this? Because after you need to make this sustainable at this particular time. Because if it's a longer time you could not control, and before then you are having the less value of this millivolt. Okay.
Yes, sir.
Yeah.
Yes.
So how do you do that? What is your future planning? That can you control this somehow?
Control the chromium toxicity, the control. Chromium toxicity control.
Okay.
Plus waste of the material is reusable, the waste of the material.
Okay.
So you throw out of the groundnut peel. So the groundnut peel not oxidized in the state of the biochar, converted in the biochar. So this material soil plus biochar gives power generation 786 millivolt.
Okay. Yeah. Thank you.
Thank you. Thanks.
Yeah, one small question. In the Nyquist plot, I hardly saw the semicircle. So you need to smoothen your graph, right? Okay, you need to increase the scale. So after that, you can measure the RS, RCT, and all those stuffs. Just I saw only a linear line. Okay, just reframe it.
Yes.
Good work. Okay. Just give a general comment about the presentation.
After going there?
Yes, sir. Okay. Would it come up?
Okay. Yeah, okay. Yeah, I would like to express my sincere thanks to all the presenters, and beyond doubt, I think you are all excellent, and we can really understand that, especially, if you just think about the students who are doing master course, they are also doing very good. So, and of course, we know that it takes time to understand, to grasp the concept, and while performing your studies, so it takes time. So, for us, of course, it is also very difficult to judge that who is the best, but from my side, I think you are all the best. It is just only the order. Okay, thank you very much, and wish you all the best for your future research work and to upgrade your research work. Thank you very much.
I request Ms. Rida Fatima of 2nd BSc Physics with Computer Application to present the vote of appreciation.
A very good evening to everyone. On the behalf of the Departments of Chemistry and Physics, I am so grateful and thankful in honoring Professor Dr. Surendra Kumar Daka, Rajdhani College, University of Delhi, for accepting our invitation to chair this session. Thank you, sir, for your valuable contribution you made as a moderator for this oral presentation on energy storage devices and presiding over the forum and making it a success. My sincere thanks to all the organizing committee members for their efforts and the technical team for their timely support. I extend my heartfelt gratitude to all the participants who took part and contributed with enthusiasm. Thank you. Have a wonderful evening. Tomorrow, please be here by 9 a.m. I request the faculty and the outside participants to receive refreshments in the Oval Room and the PG students outside JX Miller Auditorium. The volunteers will guide the outside participants to the Oval Room. UG students, please remain in the JX Miller Auditorium.